Right now, as you sit perfectly still, listening to these words, you are moving faster than any bullet ever fired, faster than any spacecraft ever launched, faster than almost anything you could ever imagine. You feel motionless. The chair beneath you feels solid. The ground feels fixed and certain. And yet, in this single second, you have already traveled hundreds of kilometers through the dark, and you will never return to the place where you started. This is why the stillness you feel is one of the most convincing illusions in all of nature. Because beneath that calm surface, you are riding a planet, a star, and an entire galaxy through a void so vast that the true scale of your motion would unsettle anyone who stopped to truly consider it. Before we begin, be sure to like the video and subscribe for more journeys into the cosmos. Now, take a deep breath and let's begin. Stillness is a feeling, not a fact. When you stand on the surface of the earth, every signal your body receives tells you that you are at rest. The wind is calm. Your coffee sits undisturbed in its cup. A dropped object falls straight down at your feet, exactly where you would expect it to land. Nothing about your daily experience hints at movement. But your senses are not built to detect motion. They are built to detect changes in motion. This is the secret behind the illusion. When you ride in a car moving at a constant speed down a smooth, straight road, you can close your eyes and feel almost nothing. You could pour a drink, read a book, fall asleep. It is only when the car accelerates, brakes, or turns that your body suddenly remembers it is moving at all. The same principle governs everything. Smooth, steady, unchanging motion is invisible to the human body. And the Earth, as it carries you through space, moves with a smoothness so perfect that no jolt, no shudder, no rush of wind ever betrays the truth. There are no bumps in the vacuum. There is no air resistance pushing back against the planet. There is nothing to brake against, nothing to turn against, nothing to remind your inner ear that you are anything but perfectly, peacefully still, and so you believe the lie. Every human being who has ever lived has believed it, at least at first. For most of our history, the idea that the ground beneath us was racing through the heavens would have sounded like madness. How could the Earth move? If it did, surely we would be flung from its surface. Surely the birds would be left behind in the sky. Surely we would feel the wind of our passage tearing at our faces. These objections felt like common sense for thousands of years. And it took some of the sharpest minds in human history to realize that common sense, in this case, was completely wrong. The truth is stranger and far more beautiful. You are not standing still. You are layered inside, motion within, motion within, motion, like a passenger asleep in a cabin, on a train, crossing a continent, on a planet, spinning through a galaxy, drifting through a universe. Each layer of that motion is faster than the last, and by the time you add them all together, the final number is so large that it stops feeling like a speed at all and starts feeling like something closer to a force of nature. So let us peel back these layers one at a time, starting with the slowest and most familiar, and working outward towards speeds that strain the limits of what the human mind can hold. The first layer is the spin of the Earth itself. Our planet turns once on its axis, roughly every 24 hours. That rotation is what gives us day and night, the rising and setting of the sun, the slow march of shadows across the ground. It feels gentle. It feels almost imperceptibly slow. But that gentleness hides a startling fact. If you are standing near the equator, the ground beneath your feet is carrying you eastward at roughly 1,670 kilometers per hour. That is faster than the speed of sound. If you could somehow detach yourself from the spinning Earth and hover motionless above its surface, the planet would tear past beneath you at over 1,600 kilometers every single hour, faster than a passenger jet at cruising altitude, faster than the crack of a whip, faster than almost anything in your everyday world. And yet you feel nothing. The reason you feel nothing is the smoothness we spoke of. The Earth has been spinning at very nearly this rate for billions of years. Everything on its surface, the oceans, the atmosphere, the rocks, your body, has been spinning along with it for your entire life. You were born already moving at this speed. You have never known anything else. There is no contrast, no comparison, no moment where the spinning stops and you can feel the difference. So the brain, finding nothing to react to, simply files the motion away as stillness. The speed of that spin depends on where you stand. At the equator, where the planet is widest, the surface must travel the greatest distance in each rotation, and so it moves the fastest. As you move toward the poles, the circles you trace each day grow smaller and smaller. Stand exactly at the North Pole or the South Pole, and you would barely move at all, simply turning slowly in place over the course of a day, like a figure at the very center of a spinning record. But for most of the people who have ever lived, scattered across the warmer middle latitudes of the planet, the spin carries them along at something like 1,000 to 1,400 kilometers per hour. This single layer of motion, the spin of the Earth, is already faster than you have likely ever traveled by any other means. And it is the slowest, gentlest layer of all the ones still to come. Consider what this spin actually does to the sky above you. When you watch a sunset, it feels as though the sun is sinking below the horizon. It is not. The sun is not moving in that moment in any way you can see. You are the one moving. The ground you stand on is rotating away from the sun, tilting your part of the world into shadow. The sunset is not the sun going down. It is you and the entire landscape around you, turning your backs to the star at 1,600 kilometers per hour. That is the first hint of the strangeness to come, the realization that the motion you attribute to the heavens is so often your own. Now we add the second layer. Because the Earth does not merely spin, it also travels. Our planet is locked in a vast circular journey around the sun, a journey that takes 1 full year to complete. We call this an orbit, and we treat it as something slow and stately, a calendar event, a thing measured in seasons rather than speeds. But the numbers tell a very different story. To circle the sun once each year, the Earth must travel a distance of nearly 940 million kilometers, tracing the enormous loop of its orbit through space. And it must complete that entire journey in 365 days. When you work out how fast that requires the planet to move, the answer is staggering. The Earth is hurtling around the sun at roughly 107,000 kilometers per hour. Let that number settle for a moment. 107,000 kilometers per hour. That is nearly 30 kilometers in a single second. Swept around the sun in a curve so vast and so gradual that you could never feel its bend. This is a speed that dwarfs everything in human experience. The fastest crewed spacecraft ever flown, the Apollo capsules returning from the moon, reached around 40,000 kilometers per hour at their peak. The Earth carries you at more than 2.5 times that speed, continuously, year after year, without engines, without fuel, without any sensation of movement at all. You are riding the fastest vehicle you will ever ride, and you have never once felt it move. And here is what makes the orbital motion so eerie when you truly grasp it. The Earth is always turning. The direction it is heading through space is constantly changing as it sweeps around the great curve of its orbit. The point in the sky toward which you are racing right now is different from the point you were racing towards 6 months ago. Half a year from now, the Earth will be on the opposite side of the sun, plunging through space in very nearly the opposite direction. You are not traveling in a straight line. You are being swung around an enormous arc, held in place by an invisible tether of gravity, reaching across 150 million kilometers of empty space. That tether is the gravitational pull of the sun, and it is the only thing keeping you from flying off into the dark in a straight line forever. Think about that balance for a moment. You are moving fast enough that, without the sun's gravity, you would simply leave. You would shoot off into interstellar space and never come back. But the sun's gravity is exactly strong enough to bend your path into a closed loop, pulling you back around again and again, year after year, in a journey that has repeated itself more than 4.5 billion times since the Earth first formed. The orbit you are riding now is the same orbit that carried the first single-celled life through space, the same orbit that carried the dinosaurs, the same orbit that will carry whatever comes after us. You are one passenger in a procession billions of years long, all moving at 107,000 kilometers per hour, all believing they are sitting perfectly still. So now we have two layers. You are spinning with the surface of the Earth at over 1,600 kilometers per hour, and you are orbiting the sun at over 100,000 kilometers per hour. These two motions combine in ways that depend on the time of day. When your part of the Earth faces in the direction of the planet's orbital travel, the spin adds to the orbital speed. When it faces the other way, the spin subtracts from it. So, your total speed is quietly fluctuating throughout the day and night, rising and falling by a few thousand kilometers per hour. As the planet turns you into and out of alignment with its journey around the sun, you never notice. You sleep through speed changes larger than any rocket launch. And yet, as enormous as this orbital speed is, it is only the second layer. We have not even left the immediate neighborhood of the sun. We have not begun to account for the motion of the sun itself. Because the sun, that anchor we orbit, that fixed point we circle, is not fixed at all. It is moving too. And it is moving much, much faster than we are. The sun is not the center of everything. For a long time, after we finally accepted that the Earth orbits the sun rather than the other way around, it was tempting to think we had found the true center of the cosmos. The sun sat still, and everything circled it. But the sun, like the Earth, is only one small body caught in a much larger motion. Our entire solar system, the sun and all its planets, moons, asteroids, and comets, is sailing through the galaxy at tremendous speed. We belong to a galaxy called the Milky Way, a vast spiral city of stars containing somewhere between 100 billion and 400 billion individual suns. And like everything else in this story, that galaxy is in motion, turning slowly around its own center, dragging every one of its stars along for the ride. The sun sits roughly 26,000 light-years from the heart of the Milky Way, far out in the quiet suburbs of one of its great spiral arms. From this position, the sun and everything bound to it, including you, is sweeping around the galactic center in an enormous circular orbit. The speed of that orbit is almost difficult to write down without feeling that you have made a mistake. The sun, carrying our entire solar system, is moving around the center of the galaxy at roughly 828,000 kilometers per hour. 828,000 kilometers in a single hour. That is more than 230 kilometers every second. In the time it has taken you to read this sentence, you have been carried more than 1,000 kilometers along the sun's path around the galaxy, a journey so vast and so smooth that the human mind has no way to register it at all. This is the third layer, and it is by far the fastest yet. Stack it on top of the others, and the picture begins to overwhelm the imagination. You are spinning with the Earth. You are orbiting the sun. and the sun is dragging you around the galaxy at well over 200 kilometers per second. Yet, even at this blistering pace, the galaxy is so unimaginably large that a single trip around its center takes a length of time almost beyond comprehension. It takes the sun somewhere between 200 and 250 million years to complete one full orbit of the Milky Way. Astronomers sometimes call this span a galactic year. Think about what that means. The last time the sun was in the position it occupies now, in this exact part of its orbit around the galaxy, the dinosaurs had not yet appeared on the Earth. The continents were arranged in shapes you would not recognize. Entire eras of life rose and fell in the time it takes the sun to travel just once around the galaxy. The sun has only completed something like 20 of these galactic years in its entire existence. Our species, modern humans, has existed for far less than a single % of one galactic year. Everything you think of as history, every empire, every war, every invention, every name ever written down, has happened in the blink of a cosmic eye, while the sun has barely shifted along its enormous galactic loop. And the whole time, you have been moving at over 800,000 kilometers per hour, without ever once feeling the wind. There is something deeply unsettling about this when you let it sink in. We tend to imagine the stars in the night sky as fixed, eternal, unchanging. The constellations look the same to us as they did to people thousands of years ago. We carve them into stories and use them to navigate, treating them as the most permanent features of our world. But they are not fixed. They are all moving, just as we are, each one carried along on its own orbit around the galactic center. The reason the constellations look unchanged across human lifetimes is simply that the distances between the stars are so colossal that even motion of hundreds of kilometers per second takes tens of thousands of years to noticeably shift their positions in our sky. Given enough time, the familiar shapes will distort and dissolve. The patterns our distant ancestors saw were subtly different from the ones we see now, and the patterns our distant descendants will see will be different again. The night sky is not a painting. It is a slow-motion swarm, every point of light a sun in flight, and we are flying right along with them. Now consider how these three layers of motion stack and weave together. The Earth's spin is the smallest, a gentle turning at the surface. The orbit around the sun is far larger, sweeping us through space at 100,000 kilometers per hour and more. And the journey around the galaxy is larger still, carrying the whole solar system at 800,000 kilometers per hour through the dark. These motions do not line up neatly. The plane in which the Earth orbits the sun is tilted compared to the plane of the galaxy. The direction the sun is heading through the galaxy is different from the direction the Earth happens to be heading around the sun at any given moment. The result is that your true path through space is not a simple circle, and not even a simple set of nested circles. It is something far more intricate, a kind of looping, corkscrewing spiral, as the Earth winds around the sun while the sun barrels forward through the galaxy. If you could trace your actual route through space over the course of a single year, accounting for all these layers at once, it would look nothing like a circle. It would look like a stretched, twisting coil, a helix drawn across hundreds of millions of kilometers of emptiness, never once retracing its own steps, always pressing forward into space you have never occupied before. You are not going in circles. You only think you are. Every birthday you have ever celebrated, every anniversary, every return of a season, feels like coming back to the same place. But you never return to the same place. The sun has moved. The galaxy has moved. The point in space where you blew out the candles on your last birthday is now tens of millions of kilometers behind you, abandoned forever, a location you will never visit again as long as you live. There is no going back in this story. Every second carries you somewhere genuinely new, and we are still not finished adding layers. Because the galaxy itself, the entire Milky Way, with its hundreds of billions of stars, its great spiral arms, its central black hole, and the small, unremarkable sun carrying you along, is also moving. The galaxy is not anchored in space any more than the sun is. It too is being pulled, drawn toward other galaxies and clusters of galaxies by the relentless force of gravity reaching across distances so vast that light itself takes millions of years to cross them. The Milky Way does not drift alone through the universe. It belongs to a small gathering of galaxies bound together by gravity, a cluster we call the local group. This group contains more than 80 known galaxies, though most of them are small and faint. Two giants dominate it. One is our own Milky Way. The other is a great spiral called Andromeda, even larger than our galaxy, lying roughly 2.5 million light-years away. Between these two giants and their many smaller companions, gravity is constantly at work, pulling, tugging, shaping the motion of the entire group. And here is one of the most remarkable facts in this entire story. The Milky Way and Andromeda are not drifting apart, they are falling toward each other. Andromeda is approaching our galaxy at roughly 400,000 kilometers per hour, drawn in by the mutual gravitational attraction between these two enormous islands of stars. The two galaxies are on a collision course, set to meet and merge in something like 4 to 5 billion years from now. When that happens, the Milky Way as we know it will cease to exist, reshaped over hundreds of millions of years into an entirely new galaxy, a vast elliptical cloud of stars born from the merger of two great spirals. You are riding a galaxy that is destined to crash into another, and even that catastrophic motion is happening so slowly, across such inconceivable distances, that to us, it looks like the stars are standing perfectly still. But the motion of the galaxies within the local group is itself only part of a larger picture. The entire local group, the Milky Way, Andromeda, and all their companions together, is being pulled through space by structures grander still. Our local group is a small outlying member of a much larger collection of galaxy groups and clusters, a sprawling structure that astronomers have come to call Laniakea. The name comes from a Hawaiian phrase meaning immeasurable heaven, and it is fitting, because Laniakea is a structure so large that the human mind cannot truly hold it. It stretches across something like 500 million light-years and contains the mass of 100,000 billion suns, woven together into a vast web of galaxies, filaments, and empty voids. And all of it is in motion, flowing slowly toward a mysterious gravitational center. There is a region deep within this enormous structure that pulls everything around it toward itself, a concentration of mass so great that it tugs at thousands of galaxies across hundreds of millions of light-years. Astronomers gave it a name that captures both their fascination and their uncertainty. They call it the Great Attractor. For decades, the Great Attractor was one of the strangest puzzles in astronomy. We could see that our galaxy and thousands of others were being drawn toward a particular patch of the sky, all flowing in the same direction as though pulled by some unseen hand. But the region they were flowing toward was almost impossible to observe directly, because it lies behind the dense, crowded plain of our own Milky Way, hidden by a curtain of stars, gas, and dust that blocks our view. We were being pulled towards something we could barely see. That alone is a haunting thought. The entire local group, carrying our galaxy, carrying the sun, carrying the earth, carrying you, is being drawn across the universe toward a destination obscured from view, a gravitational anchor whose full nature we are still working to understand. When astronomers finally added up all the velocities, all the layers of motion stacked one upon another, they arrived at a single staggering number that describes how fast you are truly moving through the universe. There is a way to measure your motion against the most absolute reference frame available to us. Spread across the entire sky is a faint glow of microwave radiation, the cooled afterglow of the Big Bang itself, the oldest light in existence, released when the universe was just a few 100,000 years old. This ancient light fills all of space, and on the largest scales it is almost perfectly uniform in every direction. It provides something close to a cosmic backdrop, a frame against which all motion can be measured. And when we measure the motion of our galaxy against that ancient light, we find that we are moving through it at an astonishing speed. Our solar system is traveling at roughly 2,200,000 kilometers per hour, relative to that primordial glow, 2 million kilometers per hour. That is more than 600 kilometers every second. In the time it takes your heart to beat once, you are carried more than 600 kilometers across the universe, swept along by all these nested layers of motion, combined into a single, relentless rush through the dark. Let that number stand for a moment without comparison or distraction. 600 kilometers per second. That is the speed at which the place you are sitting right now is moving through the deepest reference frame we know. In 1 second, you cross a distance greater than the length of many countries. In 1 minute, you travel farther than the distance to the moon would suggest, is even reasonable for a being who feels perfectly still, and you feel nothing. No wind, no pressure, no sense of speed at all. The illusion of stillness holds, even now, even as you cross 600 kilometers of universe with every passing second. This is the terrifying reality at the heart of our existence. Not that the universe is dangerous, not that something is coming to harm us, but that the ground we trust as the very symbol of solidity and permanence is in fact one of the fastest moving things we will ever know. To understand why this motion stays hidden from us, we have to understand something profound about the nature of movement itself. There is a question that sounds simple, but turns out to be one of the deepest in all of physics. How fast are you moving, really? We have just stacked up layer after layer of motion, ending with a figure of more than 600 kilometers per second. But that number was measured against a particular thing, the ancient glow of the Big Bang. Measured against the sun, your speed is different. Measured against the center of the galaxy, it is different again. Measured against the chair you are sitting in, you are not moving at all. So which of these is your true speed? The unsettling answer, the one that took humanity centuries to accept, is that there is no single true speed. There is no special, privileged place in the universe that is truly, absolutely at rest, against which all other motion can be measured as the real motion. Every measurement of speed is a comparison between two things. You can only ever say how fast something is moving relative to something else. This idea is one of the cornerstones of modern physics, and it overturns thousands of years of intuition. For most of human history, people assumed there had to be a fixed stage on which the drama of the universe played out, an unmoving floor beneath everything, a frame of absolute rest. The Earth was thought to be that floor, sitting motionless at the center, while everything else revolved around it. When we finally accepted that the Earth moves, the temptation was to hand the title of the fixed center to the sun instead. When the sun proved to be moving too, perhaps the galaxy was the true anchor. But each candidate fell in turn, and eventually physicists realized that the search itself was misguided. There is no anchor. There is no floor. There is no place in all the universe that can claim to be standing perfectly still while everything else moves around it. This was the great insight that emerged from the study of light and motion in the early part of the 20th century. The physicist Albert Einstein, building on the work of those before him, showed that the laws of physics are the same for everyone, no matter how they are moving, as long as their motion is smooth and unchanging. If you are sealed inside a windowless cabin moving at a perfectly steady speed, there is no experiment you can perform inside that cabin to determine how fast you are moving, or even whether you are moving at all. Drop a ball, and it falls straight down. Pour a drink, and it pours normally. Everything behaves exactly as it would if you were at rest. This is precisely why you cannot feel the Earth's motion. The Earth is, in effect, a vast cabin carrying you smoothly through space. Because that motion is steady and unchanging on the timescales of your life, there is no experiment your body can perform to detect it. The illusion of stillness is not a flaw in your senses. It is a fundamental feature of the universe. Motion at a constant velocity is genuinely indistinguishable from the inside, from being at rest. There is a strange comfort in this, and also a strange vertigo. The comfort is that you are not in danger from your speed. Speed itself, when it is steady, harms nothing. You could be moving at half the speed of light through some distant region of space and feel exactly as calm as you do right now, sitting in your chair. The vertigo comes from realizing how thoroughly your sense of a fixed, stable world is an illusion built on this very principle. The solidity you feel is real in its own way, but it is the solidity of a passenger on a smoothly moving vessel, not the solidity of standing on truly unmoving ground. There is no truly unmoving ground. There never was. And yet, our senses are so completely fooled that for nearly all of human history, the very suggestion of the Earth's motion was treated not just as wrong, but as absurd, even dangerous. It is worth pausing to appreciate just how hard-won this knowledge was. The people who first proposed that the Earth moves were not working from feeling or intuition. Every feeling and intuition they had told them the opposite. They were working from careful observation, from mathematics, from the patient tracking of the planets across the sky night after night, year after year. When the astronomer Nicolaus Copernicus proposed, in the 1500s, that the Earth orbits the Sun rather than the reverse, he was making a claim that contradicted the direct evidence of everyone's senses. The Earth felt still. The Sun appeared to move across the sky. Common sense was overwhelmingly on the side of a motionless Earth. But common sense was wrong, and the careful study of the heavens slowly proved it. It took generations for the idea to take hold. The astronomer, Galileo Galilei, peering through one of the first telescopes in the early 1600s, found evidence that supported the moving Earth and faced enormous resistance for daring to say so. The notion that we are not the fixed center of creation, that the ground beneath us races through the void, struck many people as not only false but deeply threatening to their place in the cosmos. And in a sense, they were right to feel the ground shift beneath them, because every advance since then has only pushed us further from the center. First, the Earth was dethroned from the center and made to orbit the Sun. Then, the Sun was revealed to be an ordinary star, far from the center of the galaxy. Then the galaxy itself was shown to be one among hundreds of billions, drifting through a universe with no center at all. At each step, the speeds grew larger and our sense of stillness was revealed to be a deeper and deeper illusion. We went from believing we were the motionless heart of everything to understanding that we are passengers moving at 600 kilometers per second through a universe that has no heart, no center, and no fixed point anywhere. That journey of understanding is one of the great achievements of the human mind, precisely because every instinct we have fought against it. So if we cannot feel this motion, and if our senses insist we are still, how do we know any of it is true? This is a fair question, and the answer reveals just how clever the human mind can be when it learns to look past its own instincts. We cannot feel the earth spin, but we can see its consequences written across the sky and the world around us. The simplest evidence is the daily turning of the heavens itself. Every star appears to wheel slowly across the night sky, rising in the east and setting in the west, tracing great arcs through the darkness. You can watch this happen over the course of a few hours, the whole sky pivoting around a point near the North Star. For a long time, people believed the sky itself was turning, the stars fixed to a great rotating sphere. But it is far simpler, and entirely correct, to understand that the sky is not turning at all. We are. The ground beneath us rotates eastward, and so the stars appear to drift westward, exactly as the scenery outside a train window appears to slide backward as the train moves forward. There are subtler clues as well. A swinging pendulum, left to swing freely for hours, will slowly change the direction of its swing over the course of a day. The pendulum itself is not turning. The earth is turning beneath it. This effect, first demonstrated dramatically with an enormous pendulum hung from a high ceiling, offered direct, visible proof that the ground we stand on is rotating, even though we feel nothing. The great weights and the great storms of the atmosphere carry the fingerprints of the spinning Earth too. The winds and ocean currents of our planet do not flow in straight lines from one place to another. They curve. Air moving from the equator toward the poles, or from the poles toward the equator, is deflected sideways by the rotation of the Earth beneath it. This is why great storm systems spin, why hurricanes and cyclones turn in vast spirals, why the weather patterns of the northern and southern halves of the planet rotate in opposite directions. These spinning storms are a visible signature of the planet's rotation, painted across the sky in clouds hundreds of kilometers wide. The Earth tells us it is spinning, if only we know how to read the signs. Our orbit around the Sun, too, leaves traces we can detect. As the Earth circles the Sun over the course of a year, our viewpoint shifts from one side of the orbit to the other, across a span of 300 million kilometers. From these two extreme vantage points, the nearest stars appear to shift their positions ever so slightly against the more distant background, the same way a nearby object seems to jump back and forth against the far wall when you look at it first with one eye, then the other. This tiny annual shift in the positions of the nearest stars is direct proof that the Earth is moving around the Sun, carrying our viewpoint from one place to another and back again each year. It is such a delicate effect that for centuries it lay beyond our ability to measure, and its absence was once used as an argument against the moving Earth. But our instruments improved, and the shift was found exactly where the moving Earth picture predicted it would be. The same effect, measured with extraordinary precision, now allows astronomers to map the distances to the stars. Our motion around the Sun has become a tool for surveying the galaxy. The grandest motions of all, the journey around the galaxy and the rush through the cosmos, are revealed through the light of distant objects. When something that emits light moves toward us or away from us, the light it sends is subtly altered. Light from an object moving toward us is shifted slightly toward the blue end of the spectrum, its waves compressed by the approach. Light from an object moving away is shifted toward the red, its waves stretched by the recession. By measuring these shifts in the light of countless stars and galaxies, astronomers can determine how each one is moving relative to us, and from that vast catalog of motions, they can reconstruct our own. It is by reading the colors of starlight that we learn the Sun's speed around the galaxy. It is by measuring the faint shifts in that ancient glow of the Big Bang, slightly warmer in the direction we are heading and slightly cooler in the direction we are leaving behind, that we measured our true speed through the universe, that figure of more than 600 kilometers per second. The motion we cannot feel is written everywhere in light, for those patient enough to measure it. This is perhaps the most beautiful part of the entire story. We are creatures utterly fooled by our own senses, convinced of a stillness that does not exist. And yet, by careful observation and reasoning, we have managed to see through the illusion completely. We have measured speeds our bodies can never feel. We have mapped motions that unfold over millions of years. We have traced our own path through a universe so vast that the light from its edge has been traveling toward us since long before the Earth existed. The same minds that are fooled by a sunset have worked out, to within a few kilometers per second, exactly how fast that sunset is carrying them through the cosmos. There is no greater testament to what careful thought can achieve than this. The truth was hidden behind the most convincing illusion imaginable, and we found it anyway. There is yet another kind of motion in this story, one stranger than all the others, because it is not really motion through space at all. It is the motion of space itself. When astronomers turned their instruments toward the most distant galaxies, they found something that defied easy explanation. Almost every distant galaxy is moving away from us. And the farther away a galaxy is, the faster it appears to be receding. The most distant galaxies are rushing away from us at speeds that climb toward the speed of light itself. At first, this seems to suggest that we sit at the center of some great cosmic explosion, with everything fleeing from us in all directions. But the truth is far more subtle and far more profound. The galaxies are not flying apart through space like fragments of a bomb. Instead, the space between them is expanding. The fabric of the universe itself is stretching, growing larger with every passing moment, carrying the galaxies along with it like raisins embedded in a loaf of bread rising in an oven. Picture that loaf of bread dough, with raisins scattered throughout it, slowly rising. As the dough expands, every raisin moves away from every other raisin. No raisin is at the center. From the point of view of any raisin, all the others appear to be receding, and the more distant ones recede faster, simply because there is more expanding dough between them. This is exactly what is happening to the universe. We are not at the center of the expansion. There is no center. Every galaxy sees the same thing we do, all the others rushing away, the distant ones fastest of all. This expansion is happening everywhere, all the time. Even in the space inside our own galaxy and the space between you and the screen you are reading, though on those small scales, gravity and the bonds between matter easily overwhelm it. But across the vast emptiness between galaxies, the expansion adds up, stretching the distances ever wider. What makes this kind of motion so strange is that it has no speed limit in the ordinary sense. Nothing can move through space faster than light. That is one of the deepest rules of the universe. But the expansion of space itself is not bound by that rule, because it is not motion through space. It is the growth of space. The most distant regions of the universe are receding from us faster than light, not because anything is traveling through space at such speeds, but because the space between us and them is being created so rapidly that the gap widens faster than light can cross it. This has a haunting consequence. There are galaxies so far away that the light they emit will never reach us, no matter how long we wait, because the space in between is expanding faster than that light can travel toward us. These galaxies are forever beyond our reach, beyond our sight, sealed off from us by the relentless growth of the cosmos. And the expansion is not slowing down. For a long time, astronomers expected that the combined gravity of all the matter in the universe would gradually slow the expansion, perhaps even reverse it one day, pulling everything back together. But careful measurements revealed something astonishing. The expansion is not slowing. It is speeding up. Some mysterious influence, woven into the fabric of space itself, is pushing the universe apart faster and faster as time goes on. We do not know what this influence is. We have given it a name, dark energy, but the name is little more than a label for our ignorance. We know it is there because we can see its effect, the accelerating expansion of the universe. But its true nature remains one of the greatest unsolved mysteries in all of science. So to the layers of motion we have already counted: the spin of the Earth, the orbit around the Sun, the journey around the galaxy, the fall of the galaxy toward Andromeda and the Great Attractor, the rush of our entire region through the ancient light of the Big Bang. We must add this final, stranger layer. The very space you occupy is growing, and on the largest scales, everything is being carried apart on a tide of expanding emptiness that nothing can resist. You are not only moving through space at extraordinary speeds, the space around you is itself in motion, swelling outward in every direction, all the time. The stillness you feel is contradicted at every possible level of reality. The ground spins. The planet orbits. The sun races around the galaxy. The galaxy falls toward its neighbors. The whole local universe streams through the afterglow of creation. And beneath it all, space itself stretches and grows, sweeping the most distant galaxies beyond the edge of what we can ever know. In the midst of all this, you sit, perfectly convinced that nothing is moving at all. Now let us return to that word in the title, terrifying, and ask what is actually frightening about all of this. The fear is not that speed will harm us. We have already seen that steady motion, no matter how fast, is perfectly safe. You could cross the galaxy at 1,000 kilometers per second and feel nothing at all. The danger of speed is never in the speed itself. It is in the change of speed. This is the crucial distinction that governs everything about how motion affects the body. Imagine you are in a car traveling at a steady 100 kilometers per hour down a straight highway. You feel relaxed, comfortable, barely aware of moving. Now imagine the car slams into a wall. In an instant, your speed drops from 100 kilometers per hour to 0. That sudden change, that violent shift from motion to stillness, is what causes harm. It was never the 100 kilometers per hour that was dangerous. It was the abruptness of the stop. The same principle scales up to the cosmic motions we have been exploring. The reason you can ride the Earth at 1,600 kilometers per hour, orbit the Sun at over 100,000, and circle the galaxy at over 800,000, all without the slightest discomfort, is that these speeds are extraordinarily steady. They do not change suddenly. The Earth does not lurch. The orbit does not jolt. The galaxy does not break. Everything moves with a smoothness that has been maintained for billions of years. But here is where the genuine unease creeps in. Imagine, for a moment, that any one of these motions could change abruptly. Imagine if the Earth's spin were to suddenly stop. The ground would halt, but everything resting loosely on the surface, the oceans, the atmosphere, every unanchored object, every living thing, would continue moving eastward at over 1,600 kilometers per hour, carried forward by the speed it had a moment before. The result would be unimaginable devastation, winds and floods of a violence the planet has never seen. This will not happen. There is no mechanism that could stop the Earth's spin in an instant. But the thought experiment reveals the truth hiding beneath your sense of stillness. You are not at rest. You are moving at tremendous speed, and the only reason it feels like nothing is that the motion is perfectly steady. Your safety depends entirely on the constancy of these cosmic motions, on the fact that the heavens are reliable, that the planet keeps spinning at the same rate, that the orbit holds its course, that the galaxy turns without lurching. The smoothness you take for granted is not a small thing. It is the difference between a peaceful life and instant catastrophe. There is a real and subtle physics here that deepens the picture. When the Earth carries you around the Sun, your path is not a straight line, but a vast curve. To travel in a curve rather than a straight line requires a constant pull toward the inside of the curve. That pull is supplied by the Sun's gravity, bending your path around its enormous loop. In principle, traveling in a curve is itself a kind of acceleration, a continuous, gentle change in the direction of your motion. But the curve of the Earth's orbit is so immense, the loop so wide, that the bending is spread out over a journey of nearly 1 billion kilometers each year. The result is a turn so gradual that no creature on Earth could ever feel it. The same is true of the Sun's enormous orbit around the galaxy, a curve so vast that it takes more than 200 million years to complete. These are turns, real accelerations, but they are turns so gentle, so spread out across such colossal distances that they amount to nothing you could ever sense. The universe turns you slowly enough that you mistake the turning for stillness. If any of these turns were tightened, if the Earth's orbit were 100 times smaller and 100 times faster, the forces involved would tear the planet apart. It is precisely because the cosmic scales are so vast that the violent speeds become gentle, survivable, even imperceptible. The terror, then, is a quiet one. It is not the terror of imminent danger, but the terror of realization, the vertigo that comes from understanding that the most fundamental sense you have, the sense of being on solid, stable, unmoving ground, is an illusion at every level. It is the unease of looking up at a calm night sky and understanding, truly understanding, that you are looking out from the deck of a vessel hurtling through the dark at 600 kilometers per second, on a journey with no destination you will ever reach and no possibility of return. Every place you have ever been is gone, left behind in space, never to be visited again. Every place you will ever be is somewhere you have never been before. You are always moving forward, always pressing into new and unfamiliar emptiness, and you can never go back. That is the strange and quiet terror at the heart of our motion through space. Not violence, but impermanence. Not danger, but the dissolving of every fixed point you ever believed in. Before we look outward to the galaxy and beyond, it is worth sitting a little longer with the speed of our orbit around the Sun, because it is the layer of motion most directly tied to the rhythm of our lives. Every year, on your birthday, the Earth returns to very nearly the same point in its orbit around the Sun, the same position from which it views the same distant stars. That return is what a year truly is. One full circuit of our planet around the star that anchors us, a journey of nearly 940 million kilometers completed at over 100,000 kilometers per hour. When you celebrate another year of your life, you are, in a very real sense, celebrating the completion of another enormous lap around the Sun, another full circuit of that vast loop through space. A person who has lived 80 years has been carried around the Sun 80 times, traveling a total distance of more than 70 billion kilometers in the simple act of living an ordinary life on Earth. 70 billion kilometers, traveled without ever leaving home, without ever feeling the motion, without ever once thinking of yourself as a traveler at all. The orbital speed also shapes something we rarely connect to motion, the very steadiness of our climate and our seasons. The Earth's orbit is very nearly circular, keeping us at a fairly constant distance from the Sun throughout the year, which keeps the flow of warmth and light relatively stable. If our orbit were sharply elongated, we would race close to the sun and then swing far away, suffering extremes of heat and cold that would make life as we know it impossible. The gentle, near-circular nature of our high-speed journey around the sun is one of the quiet conditions that makes our world livable. Our tremendous orbital speed, far from being a danger, is part of the delicate balance that allows life to flourish here at all. There is a humbling lesson hidden in this. The very speeds that sound so terrifying when we first encounter them turn out to be the conditions of our safety and our comfort. The steady spin gives us the gentle alternation of day and night. The smooth, fast orbit gives us the stable seasons and the reliable warmth of the sun. The slow, vast turning of the galaxy carries us through the quiet, life-friendly region of space we currently inhabit. Every one of these motions, fast as it is, has been part of the long set of circumstances that allowed a small, rocky world to become a cradle for living things. We do not survive in spite of our cosmic motion. In a very real sense, we survive because of it, riding the steady, balanced, beautifully ordered motions that have made our world a home. It helps to set these cosmic speeds against the fastest things human beings have ever managed to build, because only then does the gulf between our achievements and the everyday motion of the planet become clear. For most of human history, the fastest a person could travel was the speed of a galloping horse, perhaps 50 or 60 kilometers per hour for short bursts. For thousands of years, that was the upper limit of human velocity. The steam locomotive changed this, carrying people at speeds that once seemed reckless and dangerous, well over 100 kilometers per hour. Early travelers genuinely worried that such speeds might be harmful to the human body, that the air might be sucked from their lungs, that the motion itself might cause some unknown injury. It did not, of course, because steady motion is harmless. But the fear reveals how unnatural, even modest speeds felt to people who had never moved faster than a horse. The automobile pushed the limit higher, the airplane higher still, carrying us at hundreds of kilometers per hour through the sky. The fastest jet aircraft can exceed 3,000 kilometers per hour. And then came the rockets, the machines built to escape the Earth entirely. To break free of the planet's gravity and reach orbit, a spacecraft must reach a speed of roughly 28,000 kilometers per hour. This is called orbital velocity, and it represents an enormous leap beyond anything achievable within the atmosphere. A spacecraft in low orbit circles the entire Earth in about 90 minutes, crossing continents and oceans in minutes, witnessing a sunrise and a sunset every hour and a half. The astronauts aboard such a craft are moving at 28,000 kilometers per hour, and yet, floating weightless inside their vessel, they feel perfectly still, the same illusion that grips you in your chair, simply taken to a greater extreme. To leave the Earth behind entirely and journey to the moon or beyond, a spacecraft must go faster still, reaching what is called escape velocity, around 40,000 kilometers per hour. The crews who traveled to the moon hold the record for the fastest speed any human being has ever moved relative to the Earth, reaching roughly 40,000 kilometers per hour as they returned home and fell back toward the planet. For a brief moment, those travelers were the fastest humans in history. And here is the humbling truth. Even at that record-breaking speed, the fastest any human being has ever traveled, they were moving at less than half the speed at which the Earth carries all of us around the sun every single day. The greatest feat of speed in human history does not even match the ordinary, unfelt motion of our planet through its orbit. We strapped ourselves to the most powerful machines we could build, burned enormous quantities of fuel, risked everything, and reached a speed that the Earth quietly exceeds without any effort at all, while we sit at home believing we are still. Even the fastest machines we have ever sent into space, the uncrewed probes flung outward toward the sun or off into the depths of the solar system, reach speeds that, while impressive by human standards, are still modest against the backdrop of cosmic motion. A spacecraft built to skim close to the sun, accelerated by the sun's immense gravity, can reach speeds of several 100,000 kilometers per hour, the fastest objects ever made by human hands. And even these, our most extreme creations, are merely approaching the speed at which the sun carries our entire solar system around the galaxy. A speed maintained effortlessly, without engines, by every star in the sky. The lesson is clear and a little humbling. The most extraordinary speeds we can engineer are ordinary by cosmic standards. The universe moves everything at velocities that make our greatest machines look slow, and it does so without fuel, without effort, without any sense of strain, as a simple consequence of gravity and the structure of space. We are amateurs at speed, surrounded by a cosmos that has been a master of it since the beginning of time. And yet there is one speed that even the cosmos cannot exceed, a speed that stands as the ultimate limit on all motion through space. That is the speed of light. Light travels through the vacuum of space at very nearly 300,000 kilometers per second. Not per hour, per second. In 1 second, a beam of light could circle the Earth more than 7 times. It crosses the entire distance from the Sun to the Earth, around 150 million kilometers, in just over 8 minutes. This is the fastest anything can possibly travel through space, a cosmic speed limit woven into the very fabric of reality. Nothing that has mass can ever reach it, let alone exceed it. As an object moves faster and faster, approaching the speed of light, it becomes harder and harder to accelerate further, requiring ever more energy for ever smaller gains, until reaching the speed of light itself would demand infinite energy, which is impossible. So the speed of light stands as an unbreachable wall. Our true cosmic speed, that 600 kilometers per second, is enormous by every human measure, and yet it is only a tiny fraction of the speed of light, around 1/500th of it. We move fast enough to humble every machine we have ever built, and still we crawl compared to the light that fills the universe. The speed of light is more than just a limit on how fast things can travel. It does something remarkable to the nature of time itself. One of the most astonishing discoveries of modern physics is that motion affects the flow of time. The faster you move through space, the slower time passes for you, compared to someone who is moving more slowly. This is not a trick of perception or a flaw in our clocks. It is a real feature of the universe, confirmed by precise experiments again and again. At the everyday speeds of human life, the effect is so tiny as to be utterly unnoticeable, but it is always present. When you walk across a room, time passes very slightly more slowly for you than for someone sitting still, by an amount so small that no instrument could ever detect it in such a case. When astronauts orbit the Earth at 28,000 kilometers per hour for months at a time, the effect becomes just barely measurable. They return home, having aged a tiny fraction of a second, less than they would have on the ground, genuine time travelers into the future, if only by the smallest sliver. The faster the motion, the greater the effect. If we could somehow accelerate a traveler to a substantial fraction of the speed of light, the difference would become dramatic. A journey that felt like a few years to the high-speed traveler might correspond to decades or centuries passing back on Earth. This is not fantasy. It is a direct consequence of the same physics that governs the motion we have been exploring all along. Time and space are woven together into a single fabric, and motion through space trades against motion through time in a precise and unbreakable way. For us, riding the Earth at our cosmic 600 kilometers per second. The effect is real but minute. Time passes for us very slightly more slowly than it would for some hypothetical observer truly at rest against the ancient glow of the Big Bang. But the difference is so small, compared to the speed of light, that it amounts to almost nothing across an entire human lifetime. Still, the principle is humbling. Our motion through space is not separate from our motion through time. They are two aspects of a single journey through the combined fabric of space-time. Every kilometer per second we move through space subtracts, ever so slightly, from how quickly we move through time. We are not only travelers through space, we are travelers through time as well, and the two are bound together more deeply than our intuition could ever have guessed. Let us now try to picture the full shape of our journey, the actual path we trace through the universe when all the layers are combined. We have established that you are not moving in a circle, despite the way years and seasons return. You are moving in a complex, layered spiral, never retracing your steps. Start with the Earth's spin. A point on the surface traces a circle each day as the planet rotates. But the Earth is also moving forward in its orbit around the Sun, so that daily circle is dragged forward through space, stretched into a kind of coil. A point on the Earth does not return to where it was a day ago. It is hundreds of thousands of kilometers away by then, carried along by the orbital motion. So the spin, combined with the orbit, traces a coiling, looping path, like the thread of a screw winding forward through space. Now add the Sun's own motion through the galaxy. The Sun is not sitting still while the Earth coils around it. The Sun is rushing forward through the galaxy at over 800,000 kilometers per hour, and it carries the Earth's entire coiling orbit along with it. So the Earth does not really orbit the Sun in a flat circle. It traces a vast helix, a corkscrew spiraling forward through the galaxy, winding around the moving Sun as the Sun plunges ahead. The pattern is sometimes described as a kind of cosmic spiral, the planets winding around the Sun like the threads on a screw while the whole assembly drives forward through space. And we are still not done, because the Sun's path around the galaxy is itself a vast curve, bending slowly over hundreds of millions of years. And the galaxy is falling toward Andromeda and the Great Attractor, and the whole local universe is streaming through the ancient light of creation. And space itself is expanding beneath all of it. The true path you trace through the universe, when every one of these motions is combined, is a curve of staggering complexity, a spiral within a spiral within a spiral, drawn across distances that no human mind can truly hold. If you could somehow stand outside the universe and watch the trail of your own life painted through space, you would not see a person sitting still in a chair. You would see a thread of motion, thousands of millions of kilometers long, looping and coiling and spiraling through the dark, never crossing itself, never returning, always pressing forward into emptiness it has never touched before. That thread is your life, written in motion across the cosmos. Every moment you have ever lived happened somewhere along it, at a place in space you can never return to, moving at a speed you could never feel. Consider what this relentless forward motion means across the great stretches of time. Because we are always moving and never returning, the solar system has traveled through vast and varied regions of the galaxy over its long history. The part of the galaxy we occupy today is not the part we occupied in the distant past. As the Sun winds its way around the galactic center, it passes through different neighborhoods, some crowded with stars and gas, others nearly empty. Right now, our solar system happens to be drifting through a relatively quiet and empty pocket of the galaxy. Astronomers call this region the local bubble, an enormous cavity in the gas and dust of the galaxy, hundreds of light years across, carved out long ago by the explosive deaths of massive stars. These ancient stellar explosions swept the surrounding space nearly clean, leaving a vast, low-density bubble through which the sun is now passing. We are travelers crossing a clearing in a forest, a region of unusual emptiness that we did not create and will eventually leave behind. In the distant future, as the sun continues its journey, we will pass out of this bubble and into denser regions once more, where the gas and dust of the galaxy grow thick again. Some scientists have wondered whether such passages through denser regions might affect our planet, perhaps by altering the flow of particles reaching us from space, or by disturbing the distant icy bodies at the fringes of the solar system. These are slow processes, unfolding over millions of years, far beyond the span of any human concern. But they remind us that our position in the galaxy is not permanent, that we are passing through, that the cosmic landscape around us is constantly, if slowly, changing as we move. The sky our distant descendants will see, if any remain to see it, will be subtly different from ours, painted with stars in slightly different positions, viewed from a slightly different corner of the galaxy. We are not just moving fast. We are going somewhere, even if that somewhere is simply onward, forever, into regions of the galaxy we have never occupied before. There is also a slower, subtler motion of the Earth that adds yet another thread to this tapestry. The Earth does not spin perfectly upright. Its axis is tilted, leaning over at an angle, which is what gives us our seasons. But that tilted axis is not perfectly fixed in direction. It slowly wobbles, tracing out a great circle over the course of roughly 26,000 years, like the slow wobble of a spinning top as it begins to lean. This wobble means that the direction in which the Earth's axis points is gradually changing. Today, the axis points very nearly toward a particular star we call the North Star, the steady point around which the northern sky appears to turn. But thousands of years ago, the axis pointed elsewhere, toward a different star entirely. And thousands of years from now, it will point somewhere else again. The North Star is only temporarily the North Star. Given enough time, the title will pass to other stars, and eventually, after 26,000 years, return again. The ancient builders who aligned their great monuments to the heavens were aligning them to a sky subtly different from ours, a sky slowly turning beneath this great wobble of the Earth's axis. Even the apparent fixed point of the heavens, the still center around which the night sky seems to rotate, is itself slowly moving, drifting in a great circle across the stars over hundreds of generations. There is no fixed point anywhere. Not in space, not in the sky, not even in the direction your own planet points as it spins. Everything wanders. Everything moves. The wobble is gentle. Almost 26,000 years for a single circuit, far too slow to notice in a lifetime. But it is there. One more layer of motion in a universe that holds nothing perfectly still. And it raises the question that lurks behind this entire story. What holds all of this together? What keeps the Earth bound to the sun bound to the galaxy bound to its neighbors, across speeds so enormous that everything should, by all rights, fly apart? The answer is gravity, the quiet, invisible force that shapes every motion in this story. Gravity is, by far, the weakest of the fundamental forces of nature. You overcome it every time you lift a cup or climb a stair. A small magnet can pluck a paperclip off the ground, defeating the gravity of the entire Earth in that small contest. And yet, across the vast scales of the cosmos, gravity rules everything. It is weak, but it has infinite reach, and it always pulls, never pushes, so its effect adds up across enormous masses and enormous distances until it becomes the dominant shaping force of the universe. It is gravity that bends the Earth's path into an orbit around the sun, gravity that swings the sun around the galaxy, gravity that pulls Andromeda toward us across millions of light years, gravity that draws the local group toward the great attractor. Every curve in the great spiral of our motion is drawn by gravity, the patient hand that holds the cosmos together even as everything within it races through the dark. Without gravity, there would be no orbits, no galaxies, no structure at all, just matter flying apart in straight lines forever. It is gravity that takes the wild speeds of the universe and bends them into the looping, stable, survivable patterns that make worlds and life possible. The same force that makes an apple fall from a branch is the force that keeps you from flying off into interstellar space at 100,000 kilometers per hour. Gravity is the reason your tremendous speed feels like nothing, because gravity bends that speed into a smooth, closed path rather than a straight escape. We owe our stillness, our safety, and our very existence to the gentlest and most patient force in all of nature. Let us pause and gather together everything we have uncovered, all the layers of motion, into a single, clear picture. Sit quietly and imagine each layer settling onto the ones beneath it. You begin with the spin of the Earth, carrying you eastward at up to 1,670 kilometers per hour if you stand near the equator. Onto that, add the orbit of the Earth around the Sun, sweeping you along at roughly 107,000 kilometers per hour. Onto that, add the motion of the Sun around the center of the galaxy, dragging the entire solar system at roughly 828,000 kilometers per hour. Onto that, add the motion of the galaxy itself, falling toward Andromeda and being pulled toward the great attractor, along with the streaming of our entire region of the universe. When all of these are combined and measured against the oldest light in the cosmos, the ancient afterglow of the Big Bang, the total comes to that staggering figure, roughly 2,200,000 kilometers per hour, more than 600 kilometers in every single second. This is your true speed, as close to an absolute measure of motion as the universe allows. And beneath even that, the space you occupy is itself expanding, growing larger with every moment, carrying the distant galaxies ever farther away. Now hold that entire picture in your mind, all of it at once, and notice that you feel absolutely nothing. No motion, no wind, no sense of the tremendous velocities layered beneath you. The cup of coffee beside you sits perfectly still on the table. A dropped pen falls straight to the floor. The world around you is the very picture of calm and stability. This is the great paradox at the center of our existence. We are among the fastest moving things we will ever encounter, and we experience ourselves as utterly motionless. The contrast between the truth and the feeling is so vast that it borders on the absurd. If a being from outside our universe could watch you, they would see a creature racing through the cosmos at 600 kilometers per second, spiraling through a galaxy, falling toward distant clusters, riding an expanding tide of space. And that creature would describe itself, with complete sincerity, as sitting still. Consider what these speeds amount to over the course of an ordinary human life. In a single day, the motion of the sun around the galaxy alone carries you roughly 20 million kilometers through space. In a single year, that same motion carries you billions of kilometers. Over an entire human lifetime of 70 or 80 years, the distances become almost meaningless to write down. Hundreds of billions of kilometers traveled, none of it felt, none of it remembered, all of it carrying you steadily away from every place you have ever been. The room where you were born is not where it was when you were born. It has been carried billions of kilometers through space in the years since, swept along by the motion of the planet, the sun, and the galaxy. If you could somehow return to the exact point in space where you took your first breath, you would find yourself stranded in the empty dark, far from any star, in a place the Earth abandoned long ago and will never pass through again. There is no home to return to in space. The only home we have is the moving vessel itself, the planet that carries us, and it never stops, never slows, never turns back. We are all of us travelers who can never go home, because home is not a place in space. It is a place in motion, a moment that has already swept past us and vanished into the dark behind. At the very heart of our galaxy, anchoring this vast cosmic carousel, sits something almost beyond comprehension. The center of the Milky Way, the point around which the Sun and all its companion stars swing in their great orbits, is home to a supermassive black hole, a concentration of matter so dense and so massive that not even light can escape its grip. This central black hole holds the mass of roughly 4 million suns, all compressed into a region of space astonishingly small by cosmic standards. We call it by the name of the region of sky in which it sits, Sagittarius A. Around this dark anchor, the entire galaxy turns, hundreds of billions of stars wheeling in vast, slow orbits, our own sun among them, carrying us along at over 800,000 kilometers per hour. We do not orbit the black hole directly, in the sense of circling it closely. We are far away from it, some 26,000 light-years out in the galaxy's spiral arms. But the black hole, together with the immense mass of all the stars and gas and dark matter of the galaxy, defines the center around which we all turn. It is the still point, or as close to a still point as the galaxy has, the gravitational heart of the Great Wheel. And even it is not truly still, for the galaxy itself is moving through the universe, carrying its central black hole along with everything else. There is no anchor anywhere that is not itself adrift. Astronomers have watched stars near the very center of the galaxy whip around this black hole at speeds of thousands of kilometers per second, completing tight, fast orbits in mere years, swinging close to the dark center and then racing away again. These stars move so fast, so close to the monster at the galaxy's heart, that watching their motion over the years has given us some of our best evidence that the black hole is truly there. We cannot see the black hole itself, for it gives off no light, but we can see the stars dancing around it, swung through space by its enormous gravity. And from their motion, we can weigh the unseen giant at the center of it all. Far out in the calm suburbs where we live, our motion is gentler, our orbit slower, our path around the center taking hundreds of millions of years. But we are bound to the same great wheel, turning around the same dark heart, riding the same cosmic carousel as every other star in the galaxy. There is another companion in our motion that deserves attention, one far closer than any star. The moon, our constant companion, is bound to the Earth by gravity, circling us roughly once a month at a distance of about 384,000 kilometers. But the moon does not simply circle a stationary Earth. It must keep pace with everything the Earth does. As the Earth races around the sun at 107,000 kilometers per hour, the moon races alongside it, weaving in and out, sometimes ahead of the Earth in its orbit, sometimes behind, tracing its own looping path through space. And as the sun carries the Earth and moon together around the galaxy, the moon is swept along on that journey too, adding its own small monthly loop to the grand spiral of our motion. The moon, like everything else, never returns to where it was. Each month, when it returns to the same phase, the full moon rising over the same horizon, it is in fact billions of kilometers from where it was the month before, carried forward with the rest of us through the galaxy. The familiar face of the moon, seemingly so changeless, so fixed in our sky, is in truth one more traveler racing through the dark beside us, looping around our moving planet as we all hurtle forward together. And here is a quiet detail that captures the impermanence of everything. The moon is slowly drifting away from the Earth, receding by a few centimeters each year, gradually loosening the bond between us across hundreds of millions of years. Even our nearest neighbor, our oldest companion in the sky, is slowly leaving us, carried apart by the subtle physics of tides and time. Nothing in this cosmos stays where it is. Nothing holds still. Everything is in the process of arriving from somewhere and departing towards somewhere else. Beyond the visible stars and the glowing gas, there is something else holding the galaxy together, something we cannot see at all. When astronomers measure how fast the stars at the edges of galaxies are moving, they find a deep puzzle. The stars at the outer fringes of the Milky Way and of other galaxies are moving far too fast. By all the rules of gravity, with only the visible matter we can see to hold them, those outer stars should be flung off into intergalactic space, the galaxies torn apart by their own rotation. And yet the galaxies hold together. Something unseen is providing the extra gravity needed to keep the fast-moving outer stars bound in their orbits. We call this unseen something dark matter, and like dark energy, the name is mostly a confession of how little we understand it. We know it is there because we can feel its gravity, holding the galaxies together against the speeds of their own stars, but we cannot see it, cannot touch it, cannot capture it in any instrument. It gives off no light, casts no shadow, and passes through ordinary matter as though it were not there. And yet there is far more of it than there is of everything we can see. For every kilogram of ordinary matter in the universe, the stars, the planets, the gas, the dust, your own body, there are several kilograms of this invisible dark matter, woven through the cosmos in vast, unseen halos around every galaxy. The galaxy you ride, the great wheel that carries you around at 800,000 kilometers per hour, is held together largely by a substance we cannot see and do not understand. An invisible scaffolding of dark matter without which the whole structure would fly apart. Your tremendous, steady, unfelt speed is made possible by the gravity of something that remains, to this day, one of the deepest mysteries in all of science. You are bound into your cosmic motion by an invisible hand. The more we learn about our journey through space, the more we discover that the universe is shaped by influences we can barely perceive. The visible stars and galaxies, all the light in the cosmos, turn out to be a thin froth on the surface of something vaster and darker, dark matter providing the gravity, dark energy driving the expansion, the two of them together making up the overwhelming majority of everything that exists, and both of them invisible, mysterious, unknown. We ride our great spiral through a universe that is mostly hidden from us. Our tremendous speeds governed by forces we are only beginning to glimpse. There is a strange intimacy in realizing that everything around you shares this hidden motion. The people you love, the strangers you pass on the street, the trees outside your window, the oceans and the mountains, every living thing and every still object, all of it moves with you, at the same tremendous speed, in the same direction, through the same dark. You have never once been separated from your fellow travelers by even a fraction of this cosmic velocity. When you walk across a room towards someone, the few kilometers per hour of your footsteps is utterly trivial against the 600 kilometers per second you are both already sharing. In the great scheme of motion, you and everyone you have ever known are moving in near-perfect lockstep, a single human cargo riding one small world through the galaxy together. There is something deeply reassuring in that thought. We may each feel alone in our own small lives, but at the level of our motion through the cosmos, we have never been alone for an instant. We are all passengers on the same vessel, bound together by the same gravity, carried forward at the same speed toward the same unknown future. The entire human story, every life that has ever been lived, has unfolded aboard this single moving world. All of us traveling together, none of us ever left behind. And it is not only the living who share this journey. Every person who has ever existed rode this same motion, spun with this same earth, orbited this same sun, wheeled around this same galaxy. The motion connects us not only to one another across the distances of the present, but to everyone who came before us across the depths of time, all of us travelers on the same endless journey, separated only by when we happen to ride. What, then, would it take to truly stop? Suppose you wanted to be genuinely at rest, motionless against the ancient light of the Big Bang, the closest thing to absolute stillness the universe offers. You would first have to cancel the spin of the Earth carrying you eastward, then cancel the orbital motion around the Sun, more than 100,000 kilometers per hour. Then cancel the Sun's motion around the galaxy, over 800,000 kilometers per hour. Then cancel the motion of the galaxy through the local group, and the streaming of the local group through the universe. You would have to fire engines of unimaginable power, shedding velocity in every direction at once, fighting against motions layered over billions of years, until at last you came to rest against the cosmic backdrop. And what would you find? Having achieved this perfect stillness, you would find yourself utterly alone, motionless in the dark, while the Earth, the Sun, the entire galaxy, and everyone you have ever known went streaming away from you at 600 kilometers per second, dwindling into the distance, gone within moments. To be truly still is to be abandoned by everything, to watch your whole world race away into the void. Stillness, it turns out, is not peace. Stillness is exile. The motion we cannot feel is not a curse, but a belonging. It is the proof that we travel together, the whole Earth, the whole human family, every living thing, all of us riding the same vessel through the same dark at the same tremendous speed. We move as one, and because we move as one, we feel as though we do not move at all. Our stillness is the stillness of companionship, the calm of fellow travelers who have never once been left behind. It is worth dwelling for a moment on what it would actually take to feel any of this motion, because the answer reveals something deep about the nature of speed. The only way to feel motion is to feel it change. A passenger in a smoothly cruising aircraft feels nothing, until the plane hits a patch of turbulence and the body is suddenly jolted, lifted, dropped. It is the change that registers, never the steady speed. For you to feel the Earth's orbit around the Sun, the orbit would have to suddenly speed up or slow down, or change direction sharply, and it never does. For you to feel the Sun's journey around the galaxy, that journey would have to lurch or break, and it never does. The cosmic motions are so steady, so perfectly maintained, that there is simply nothing for your body to react to. This is why even the astronauts who travel into orbit, moving at 28,000 kilometers per hour, feel weightless and still rather than fast. Once their spacecraft stops accelerating and settles into a smooth orbit, the tremendous speed becomes imperceptible to them, exactly as the Earth's motion is imperceptible to us. They float, calm and untroubled, circling the entire planet every 90 minutes, and their bodies tell them they are perfectly still. The illusion that grips us on the ground grips them in orbit just the same, because it is not really an illusion of our particular situation. It is a fundamental truth about steady motion everywhere in the universe. Speed alone is silent. Only change speaks to the body. Now, consider the sheer scale of the distances these speeds carry us across, because the numbers alone are difficult to hold in the mind. In a single second, moving at our true cosmic speed, you cross more than 600 kilometers, a distance that would take hours to drive. In a single minute, you travel tens of thousands of kilometers. In a single hour, more than 2 million kilometers, a distance several times greater than the gap between the Earth and the Moon. These distances pile up with a relentlessness that defies imagination. The space you occupied at the start of this sentence is already thousands of kilometers behind you, abandoned forever. The space you occupied an hour ago is millions of kilometers away, unreachable, gone. We tend to think of distance as something we must work to cross, something measured in the effort of travel, the fuel burned, the hours spent. But the universe crosses these distances for us, constantly, effortlessly, whether we will it or not. We are the most well-traveled beings imaginable, crossing distances every day that dwarf the entire history of human exploration. And we do it sitting perfectly still, unaware, asleep, or absorbed in the small concerns of our small lives. The grandest journey in all of existence is happening to you right now, and it asks nothing of you, not even your attention. Zoom out far enough, and the structure of the universe itself comes into view, and with it, the grandest pattern of our motion. On the very largest scales, the galaxies of the universe are not scattered randomly through space. They are arranged into a vast, intricate structure that astronomers call the cosmic web. Galaxies gather along immense filaments, threads of matter stretching across hundreds of millions of light years, like strands of a spider's web spun across the dark. Where these filaments cross, great clusters of galaxies gather, dense knots in the web, containing thousands of galaxies bound together by gravity. And between the filaments lie the voids, enormous bubbles of nearly empty space, regions so vast and so empty that a traveler within one could look out and see almost nothing at all. The nearest galaxies hundreds of millions of light years away. This is the architecture of the universe, the largest pattern that exists, a web of light and matter strung across a darkness of unimaginable scale. And we are part of it. Our galaxy sits within one of the filaments of this cosmic web, part of the flow of matter draining slowly along the threads toward the great gathering points. The motion we have traced, the streaming of our galaxy toward the great attractor and beyond, is, in truth, the motion of matter flowing along the strands of the cosmic web, drawn by gravity toward the densest knots. You are not only riding a planet, a star, and a galaxy. You are riding a current in the largest river that exists, the slow gravitational flow of matter through the cosmic web, moving along a filament that stretches farther than the mind can follow. Your cosmic address, written out in full, captures the dizzying scale of where you live and where you move. You live on the Earth, which orbits the Sun, which lies within the local bubble, within one of the spiral arms of the Milky Way galaxy, which belongs to the local group of galaxies, which sits on the outskirts of the great supercluster called Laniakea, which is part of the cosmic web that fills the observable universe. Each level of that address is a level of motion, the Earth spinning, the Sun orbiting, the galaxy turning, the group falling, the supercluster streaming, all of it carried on the expanding tide of space itself. You do not have one speed. You have a whole nested hierarchy of speeds, each one stacked upon the last, all the way up to the largest structures that exist. And every level of it is hidden from your senses behind the perfect, seamless illusion of stillness. What is the destiny of all this motion? Where, in the end, is this great journey taking us? The honest answer, drawn from our best understanding of the universe, is sobering. Because the expansion of space is accelerating, driven by the mysterious dark energy, the universe of the far future will be a lonelier place than the one we know. Over immense spans of time, billions upon billions of years, the accelerating expansion will carry the distant galaxies ever farther away, faster and faster, until their light can no longer reach us at all. One by one, the galaxies beyond our local gathering will slip past the horizon of what we can see, their light stretched and dimmed into invisibility, until the sky beyond our own neighborhood goes dark. Our own local group, bound together by gravity, will hold together and eventually merge into a single great galaxy. But beyond it, the rest of the universe will recede into an unreachable distance, leaving our descendants, if any remain, alone in an island of light surrounded by an ever-growing ocean of darkness. The motion that today connects us to the wider universe will, in the deep future, carry that universe out of reach entirely. This is not a tragedy on any human scale, for it unfolds across time spans so vast that the entire history of life on Earth is less than a flicker against it. But it is a reminder that the motion we ride is not a stable, eternal arrangement. It is part of a story with a beginning and a direction. A universe that began in a hot, dense state, expanded and cooled, gave rise to stars and galaxies and life, and will continue to expand, spreading thinner and colder and more isolated across an unimaginable future. We happen to live in an early, bright chapter of that story, when the galaxies are still close enough to see, when the stars still shine, when the universe is still young enough to be full of light. Our motion is part of the unfolding of that chapter, the slow flowing of matter through the cosmic web, the gathering of galaxies, the turning of the great wheels of gravity. We are here for a brief, luminous moment in the long life of the cosmos, riding our planet through a universe still full of wonders, still full of light, still close enough to know. There is something almost unbearably poignant in this. The very motion that carries us forward is also, on the largest scale, carrying everything apart. The universe is growing more isolated, even as we reach out to understand it. We are learning the true scale of the cosmos at the very moment in its history, when that cosmos is most knowable, most full, most connected, before the long darkness of expansion carries the distant galaxies forever beyond our sight. Future beings, born trillions of years from now in some last island galaxy, may look out at an empty sky and never know that a wider universe of galaxies once filled it. Never guess at the cosmic web, never measure their motion against the ancient glow of a Big Bang, whose light will by then have faded beyond all detection. We are fortunate, in a way that is easy to overlook, to be alive at a time when the universe still tells us its story, when we can still measure our speed against the oldest light in existence, when we can still trace the great spiral of our journey through a cosmos that has not yet hidden its secrets behind the veil of its own expansion. Let us bring all of this back down to the scale of a single ordinary day, your day, and see it transformed by what we now understand. You wake in the morning, and the sun rises through your window. Except the sun is not rising. You are turning toward it. You're part of the Earth rotating eastward at well over 1,000 kilometers per hour, swinging your bedroom around to face the star you orbit. You pour your coffee, and it sits calmly in the cup, while you and the cup and the kitchen around you race around the sun at over 100,000 kilometers per hour. The entire scene swept forward through space faster than any rocket. You step outside, and the ground feels solid and still beneath your feet, while that ground carries you and the city and the continent around the center of the galaxy at over 800,000 kilometers per hour, the whole solar system plunging through the dark together. You look up at the daytime sky, blue and quiet, and beyond it, the entire local universe streams through the ancient light of the Big Bang at 600 kilometers in every second of your morning. By the time you have finished your coffee, you have traveled tens of thousands of kilometers through the galaxy. By the time you sit down to lunch, hundreds of thousands. By the time you go to sleep at night, having done nothing more strenuous than live an ordinary day, you have been carried millions upon millions of kilometers through space to a place the Earth has never been before and will never return to. Tomorrow you will wake in an entirely new location in the universe, billions of kilometers from where you woke today, and you will feel exactly as still as you did this morning. Every night, when you lie down to sleep, you are not resting in place. You are being carried through the cosmos at 600 kilometers per second, dreaming as you fly, traveling farther in your sleep than any explorer in history traveled in a lifetime. When you wake, the place where you fell asleep is millions of kilometers behind you, lost forever in the dark, and you have arrived somewhere new without ever leaving your bed. This is the quiet wonder hiding inside the most ordinary moments of your life. You are an explorer, whether you know it or not, a traveler crossing distances no map could hold, and you do it without effort, without thought, simply by existing on the surface of a moving world. The greatest journey you will ever take is the one you are taking right now, sitting still. It is worth asking why this knowledge should feel terrifying at all, rather than simply wondrous. Part of the unease, surely, comes from the loss of solid ground. We build our entire sense of security on the idea of stable, unmoving earth beneath us. The very word we use for reliability, for being grounded, comes from this trust in the solidity of the ground. To learn that the ground is racing through space at 600 kilometers per second is to feel that foundation tremble. To sense that the most basic certainty of our lives is, in a deep sense, an illusion. But there is another way to hold this knowledge, one that turns the terror into something closer to awe. The motion was always there. It did not begin when you learned of it. You have been traveling at these speeds your entire life, through every peaceful moment, every quiet morning, every night of untroubled sleep. The tremendous velocity never once harmed you, never once disturbed your rest, never once intruded on the gentle, ordinary texture of your days. If anything, the knowledge of your true motion should deepen your trust in the universe rather than shake it, because it reveals just how reliable, how steady, how astonishingly smooth the cosmos truly is. For billions of years, the Earth has spun without faltering. For billions of years, the orbit has held its course. For billions of years, the galaxy has turned without a lurch. The universe has carried you and every living thing before you at unimaginable speeds, and it has done so with a gentleness so perfect that not one of us has ever felt a thing. That is not a cause for terror. That is a cause for a kind of gratitude, a recognition that we ride a cosmos of extraordinary order and reliability, a great machine of gravity and motion that has kept its rhythm since long before life began and will keep it long after we are gone. The terror, if we choose to call it that, is really the vertigo of awakening, the dizziness that comes from suddenly seeing past an illusion we have trusted all our lives. And like all such awakenings, it can settle, given time, into something deeper and calmer, a sense of our true place in a universe far larger, far older, and far more magnificent than our senses ever let us guess. Even the people of the distant past, who had no telescopes and no equations, seem to have sensed, in their own way, that the heavens were full of motion. They watched the sky turn each night and built stories to explain it. Tales of the sun being carried across the sky, of the stars wheeling in their courses, of the heavens as a great turning dome. They were wrong in their explanations, attributing the motion to the sky rather than to themselves. But they were right that the cosmos was in motion, that the heavens never held still. They aligned their monuments to the rising and setting of the sun, tracked the slow march of the constellations through the seasons, and noticed the wandering of the planets against the fixed stars. In their myths and their monuments, they were grappling, however imperfectly, with the same truth we have been exploring: that we live in a universe of ceaseless motion, that nothing in the heavens stays still. It took thousands of years, and the slow accumulation of careful observation and bold thinking, to turn that intuition into understanding, to realize that the motion they saw in the sky was in large part our own, that we were the ones turning, the ones orbiting, the ones racing through the dark. The journey from those ancient sky watchers to our modern understanding is itself one of the great motions of history, the slow turning of human knowledge toward the truth, and it is not finished. We still do not know what dark matter is, or dark energy, or what lies beyond the edge of the observable universe, or whether our cosmos is one of many. The journey of understanding continues, just as our journey through space continues, both of them pressing forward into territory we have never explored before. Consider, for a moment, the sheer ingenuity it took to measure our true speed through the universe. The ancient afterglow of the Big Bang, that faint glow of microwave radiation filling all of space, is almost perfectly uniform. In every direction you look, it has very nearly the same temperature, a cold whisper just a few degrees above the coldest possible temperature, the same to an extraordinary degree of precision across the entire sky, but not quite the same. Because our galaxy is moving through this ancient light, the glow is very slightly warmer in the direction we are heading, and very slightly cooler in the direction we are leaving behind. The difference is minuscule, a tiny fraction of a degree, a warming and cooling so slight that detecting it required instruments of breathtaking sensitivity. Yet by measuring this faint warm spot and cool spot in the ancient light, astronomers could read off the direction and speed of our motion through the universe, like a sailor feeling the warmth of the wind on one cheek and the cool on the other, and deducing the direction of travel. This is how we know our true cosmic speed, that figure of more than 600 kilometers per second. We measured it by reading the faintest imaginable signal in the oldest light that exists, a signal so subtle that it lay beyond our reach until our instruments grew sensitive enough to detect a temperature difference smaller than the breath of a single thought. The fact that we can measure such a thing at all is among the most remarkable achievements of the human mind. We took the cooled remnant of the birth of the universe, an echo from nearly 14 billion years in the past, and used it as a speedometer for our entire galaxy. There is something profound in that, the idea that the universe carries within it, in its oldest light, the record of our own motion, written so faintly that only the most patient and careful observers could ever read it. We are moving, and the universe itself has kept the receipt. The motion we ride also does something strange to our sense of the present moment, of what we mean when we say now. Because light takes time to travel, everything you see in the sky is a glimpse of the past. The sun you see is the sun as it was 8 minutes ago, for that is how long its light took to reach you. The stars you see at night are glimpses of years, centuries, or thousands of years ago, depending on their distance. The most distant galaxies you could observe are seen as they were billions of years in the past, their ancient light only now arriving after a journey longer than the age of the Earth. When you look up at the night sky, you are not seeing the universe as it is now. You are seeing a vast collage of different moments in the past, each star and galaxy shown to you as it was when its light departed, all of it arriving together in your eyes in this single instant you call the present. And all the while, you and everything you see have been moving, the light crossing the gap between you and its source while both of you traveled through space. The notion of a single, universal now, a present moment shared by all of existence, turns out to be far more slippery than it seems. In a universe of finite light speed and ceaseless motion, the present is local, personal, bound to your own position and your own moving frame. What counts as the same moment for you may not be the same moment for a traveler moving differently through space. This is one of the deepest and most counterintuitive lessons of modern physics, that motion reshapes not only space but time, not only where things are, but when they are. The steady, universal river of time that we feel so certain of is, like the solid ground beneath us, a comforting illusion, true enough for daily life but quietly false at the foundations of reality. We move through space, and in moving, we move through time as well, and the simple, shared present we imagine dissolves into something far stranger and more wonderful the more closely we examine it. There is one more thread to draw together before we close, and it brings the whole vast story home to the matter of your own body. You are made of atoms, and those atoms have a history bound up entirely with the motion of the cosmos. The hydrogen in the water of your body formed in the first minutes after the Big Bang, nearly 14 billion years ago, and has been traveling through space ever since, carried through clouds and stars and worlds before becoming part of you. The heavier elements in your body, the carbon in your cells, the calcium in your bones, the iron in your blood, were forged in the hearts of ancient stars, stars that lived and ended long before the sun was born. When those stars reached the ends of their lives and scattered their material into space, that material drifted through the galaxy, carried along on the same great motions we have been tracing, until some of it gathered into the cloud that became our solar system, and eventually into the world that became you. Every atom in your body has been traveling through the galaxy for billions of years, riding the same currents of gravity and motion, swept around the galactic center countless times before ever assembling into a living thing. You are not separate from the great motion of the cosmos. You are made of it, built from material that has been in motion since the beginning, briefly gathered into the shape of a person, still moving, still traveling, still part of the endless journey of matter through space. When you feel still, you are feeling the temporary stillness of atoms that have wandered the galaxy for ages, paused for a cosmic instant in the form of you, before continuing onward as they always have and always will. The motion in this story is not something happening to you from the outside. It is the very substance of what you are, the inheritance written into every atom you carry. The long journey of the universe briefly made aware of itself in the form of a being who can look up and wonder, and finally understand how fast it has been moving all along. There is a question that naturally arises from all of this, and it is worth dwelling on. If we are moving so fast, in so many directions at once, how can the universe possibly remain so orderly? How can the stars keep their patterns, the seasons keep their rhythm, the days keep their length, when everything is racing through space at such tremendous speeds? The answer lies in the difference between speed and arrangement. Imagine a great flock of birds wheeling together through the sky. Each bird may be flying at considerable speed, yet the flock holds its shape. The birds keeping their positions relative to one another, even as the whole formation sweeps across the heavens. From the point of view of one bird, the others seem almost still, their relative positions barely changing, while together they all rush forward through the air. The cosmos is much the same. The Earth and the Sun move together through the galaxy, keeping their relationship even as they race along. The Sun and its neighboring stars move together around the galactic center, drifting only slowly relative to one another even as they sweep through space at hundreds of kilometers per second. The whole galaxy moves as a single great formation. Its stars bound together by gravity, holding their grand spiral shape across hundreds of millions of years, even as the entire structure plunges through the universe. This is why the patterns endure. It is not that things are standing still. It is that they are moving together in formation, their shared motion canceling out from our point of view and leaving only the slow, gentle drift of their relative positions. The constellations hold their shapes not because the stars are fixed, but because we and they are moving together. Neighbors traveling side by side through the galaxy, our shared velocity invisible to us precisely because we share it. The orderliness of the heavens is not the orderliness of stillness. It is the orderliness of a vast and graceful procession, every member moving in concert with the others, the whole cosmos flowing together through the dark in patterns that gravity has shaped and maintained since the beginning of time. It is worth lingering, too, on just how recently we came to understand any of this. For all but the last few centuries of human existence, no one knew the Earth orbited the Sun. For all but the last century or so, no one knew the Sun orbited the center of a galaxy, or even that other galaxies existed at all. The realization that the faint smudges of light in the night sky were entire other galaxies, islands of hundreds of billions of stars each, came within the last 100 years. The measurement of our true speed against the ancient light of the Big Bang came more recently still. The understanding of dark matter and dark energy, the invisible influences that shape our motion and the fate of the cosmos, belongs almost entirely to living memory. We are, in a real sense, the first generations of human beings to know how fast we are truly moving through space. Every person who lived before this brief modern moment lived and died believing, at least in their bones, that the ground beneath them was still. The kings and the laborers, the philosophers and the poets, the builders of every ancient wonder, all of them rode the same tremendous motion we ride, and none of them knew it. We are the ones who finally pulled back the curtain, who measured the speeds, who traced the spiral, who read the receipt the universe kept of its own motion in the oldest light that exists. That is an extraordinary inheritance, and an extraordinary responsibility. We are the generation that knows, and what we do with that knowledge, how we let it reshape our sense of our place in the cosmos, is up to us. It can be a source of vertigo, a dizzying loss of the solid ground we always trusted. Or it can be a source of wonder, an invitation to feel ourselves as part of something vast and ancient and magnificent, travelers on a journey that began before the Earth existed and will continue long after we are gone. The motion was always there. We simply, at last, learned to see it. Step back now and take in the whole of what we have uncovered, the full architecture of our motion through the universe. It begins with something so small and familiar that we never think of it as motion at all. The gentle turning of the ground beneath our feet, carrying us through day and night at over 1,000 kilometers per hour. We never feel it, because we were born already turning, and everything around us turns with us in perfect unison. Onto that turning, we discovered the great curve of our orbit, the Earth swinging around the Sun at over 100,000 kilometers per hour, tracing an enormous loop that takes a year to complete and that we mistake for the simple passage of the seasons. We never feel it, because the curve is so vast and so smooth that the bending of our path is spread across a journey of nearly 1 billion kilometers every year. Onto the orbit, we found the still grander motion of the Sun around the galaxy, dragging our entire solar system through the dark at over 800,000 kilometers per hour, on a journey so immense that a single circuit takes more than 200 million years. We never feel it, because the galaxy turns us so slowly, across such unfathomable distances, that the most violent speed becomes the gentlest drift. Onto the galaxies turning, we found the fall of our whole galaxy toward its neighbors, the rush of Andromeda toward us, the streaming of the entire local group toward the hidden mass of the Great Attractor, the flow of our region along the filaments of the cosmic web. And measured against the oldest light in the universe, the cooled afterglow of the Big Bang, all of these motions combine into a single staggering velocity, more than 600 kilometers in every second, a speed that no machine we have ever built can match, sustained without effort, without fuel, without the faintest sensation of movement. And beneath all of it, woven through every scale, the very fabric of space expands, growing larger with each passing moment, carrying the distant galaxies forever beyond our reach. This is the reality, the true and terrifying and magnificent reality of how fast you are moving through space. Not still, never still. Layered inside motion within motion within motion, spiraling forward through the cosmos at speeds your body was never built to sense, on a journey with no destination you will ever reach and no place you can ever return to. Every fixed point you ever trusted is an illusion. The solid ground turns. The steady sun races. The eternal stars wander. The very space between things grows. And through it all, you sit, perfectly convinced that nothing is moving at all, held in the gentle, seamless, unbroken illusion of stillness that the universe has wrapped around you since the day you were born. But now you know better. Now, when you sit quietly in a calm moment, you can feel, not with your body but with your understanding, the tremendous motion carrying you forward. You can sense the planet turning, the orbit curving, the galaxy wheeling, the whole local universe streaming through the ancient dark. You can know yourself for what you truly are, a traveler of extraordinary speed and ancient origin, made of material that has wandered the galaxy for billions of years, briefly gathered into a being who can look up at the sky and finally comprehend the journey it has always been on. The next time you watch a sunset, remember that the sun is not going down. You are turning away from it, swinging around to face the dark at over 1,000 kilometers per hour, while the whole world races on around the sun, around the galaxy, through the streaming universe. The next time you lie awake at night beneath the stars, remember that those points of light are fellow travelers, each one moving through the galaxy as you are. The whole sky, a slow-motion swarm of suns in flight, and you flying right along with them. The next time you feel the comforting solidity of the ground beneath your feet, remember that this solidity is the solidity of a vessel in smooth and steady motion, the calm of a passenger who has never once been jolted in a journey billions of years long. There is no still ground anywhere in the universe. There never was, and there never will be. There is only the great and graceful motion of all things, the turning of worlds, the wheeling of galaxies, the patient flow of matter through the cosmic web, and you, a small and conscious part of it, carried forward forever into a future no one has ever seen. We began with the illusion of stillness, the perfect calm you feel as you sit reading these words. We end with the truth behind that calm, a truth not of danger but of wonder, the realization that the most fundamental sense you possess has been quietly fooling you your entire life, hiding a journey of staggering speed behind a feeling of perfect peace. And perhaps that is the deepest lesson of all, that the universe is far stranger, far grander, and far more astonishing than our senses alone could ever reveal, and that the only way to truly know it is to look past the comfortable illusions and follow the evidence, however dizzying, toward the truth. You are moving faster than you ever imagined, through a cosmos larger than you can hold in your mind, on a journey older than the earth and longer than any life. And the most extraordinary thing of all is that, For this one brief and luminous moment, you are here to know it. If this journey through the true speed of our existence left you seeing the ground beneath you a little differently, be sure to like the video and subscribe for more journeys into the cosmos. The next time you feel perfectly, peacefully still, remember the truth of where you really are, racing through the dark at 600 kilometers per second, carried by a planet, a star, and a galaxy. Forever forward, never back, on the greatest journey you will ever take without moving a single muscle.